An object starts from rest with an acceleration of 2 meter per second. No, this is not 2 meter per second square. After 5 seconds, the direction of acceleration reverses again for 5 seconds. Then the new displacement is. This is a really good question. I'll just give the diagrammatic representation first and then we'll solve it. See, let us say the object is moving from A to C through B. So at this point, the initial velocity is equal to 0 and the object is moving with an acceleration of plus 2 meter per second square. After 5 seconds, which means it has traveled for 5 seconds, the direction of acceleration reverses. Mind you, the direction of acceleration reverses and not the direction of motion, which means the body is still moving in the same direction, but acceleration here becomes minus 2 meter per second square. Or in other words, this much region was the region where the body was under acceleration, and now the body has started decelerating. Right? Okay. Now, let us say displacement is AB in first case and displacement is BC in the next case. Okay. And let us call that as say x1 and x2. Now, for the motion along AB, what is given? U is equal to 0, A is equal to 2 meter per second square, time is equal to 5 seconds, and we have x1. Okay. Now, for this motion, what is displacement time relation? S is equal to ut plus half a t square. U is 0, therefore this term gets eliminated. S here is x1, so x1 is equal to half into acceleration is 2 and time is 5, so this is 5 square. So basically what we get is x1 is equal to 25, and since all the units are in meter, acceleration is also in meter per second square, so this x1 is 25 meter. Now what happens is, along AB, we know that V is equal to U plus AT, right? V is equal to, U is 0 because the body starts from rest. What is A? A is 2, and what is T? T is 5 seconds, which means V is equal to 10 meter per second. Now, what is the significance of this velocity? This velocity means the velocity is for the movement of body along BC. The initial velocity is velocity at B, which is VB, what we just found out as 10 meter per second. Now, what is the time taken? The time taken is given that it is again for 5 seconds. So this much time T2 is basically for 5 seconds. And acceleration is given as minus 2 meter per second square. Now, what we need to understand is, since we are finding out BC, which is basically x2, we can directly apply the formula, which is S is equal to ut plus half a t square. What is S? S is x2. What is u? It is t. So this is 10 into, what is t? T is 5. 5 plus half into a is not 2, it is minus 2 times t square is 5 square. So x2 becomes 10 into 5 is 50. 2 and 2 will cancel off. So 2 square minus 50 minus 25, which is basically 25. Now, the new displacement is being asked in the question, right? So we can say that the new displacement is basically AC, which is equal to AB plus BC, which is equal to 25, or to be more precise, is basically x1 plus x2, which is nothing but 25 plus 25, which is 50 meters. So the correct option here is option B.